measuring an angle. Under here, right? Measuring an angle. Measuring an angle. I'll explain this using an example, right? Let's say example 1. So on the spectrometer, you have the main scale, right? Let's say 0 is here. Here you have 90 degrees. You can draw this with me. 0, 90 degrees, 180, 270 degrees, and again 0 and 360 are the same place. So this is the main scale. Right? Main scale. Then you have vernier scale. Actually, two vernier scales. In the spectrometer, you have two vernier scales. You separately measure angles from right vernier scale and then the left vernier scale. Left vernier scale is like this. Right? You take measurements from right vernier scale and left vernier scale separately, and you can take the average. That's the only reason it is there. So when you rotate the telescope, right? Remember the collimator is fixed to the stage, but you can rotate the telescope. So as you're rotating the telescope, uh, the main scale is attached to the telescope. So when you're rotating the telescope, main scale rotate with it, right? So you using this one, you can measure how much is the rotation angle of telescope, right? So you can observe from here. So let's say you have a position of the telescope here. You have positioned the telescope here. Then you can get the reading. So let's say this is position of telescope is T1. For the T1, let's say what's the right side vernier reading for the T1. So it is about 105, right? It is beyond 90 degrees. So let's say it is about 105 degrees. Actually, you can read up to minutes, 105, 12 minutes like that. But for the simplicity, I'll only include degrees. So the T1 position, it is 105 degrees. From the right side, you read 105. From the left side, let's say you read about 285, right? 285. So that is for the T1 position. Then let's say for a different position, you move the telescope like upwards. You can draw this with me, right? So this is the T. So you have 0 here, 90 degrees, 180, 270. Again 360 here. Now let's say T2 reading is 40. For this position, reading is 40 from the right side. So 40 is about somewhere here. So we have the vernier scale. Then 180 degrees apart, we have the another vernier scale. So this is right side, this is left side, left vernier. Let's say then the telescope is somewhere here because it is rotated now, right? So for the T2, this reading is about 40 degrees. So from the left side, you can just add 180 to this one. So you get 220. You don't get 220 exactly, right? From the other scale, you get a different value for the left reading. Different value means it can be changed by a few minutes, right? But for the simplicity, I took it as I just added 180 here, right? Uh, then we can say angle measured by right. So you can separately find that angle measured using right scale. So for right scale, for the T1 it is 105, for the T2 position it is 40 degrees. If you take the difference of these two, you can take the angle that the telescope rotated by using right vernier scale. So 105 minus 40. So what's the value? It's about 65 degrees, right? So this is using right vernier scale. Then we get angle measured by left vernier scale. So what is that? It is 285 minus 220. So we got for that as well 65 degrees. Usually we don't get exactly same answers, right? Because when you're doing the experiment, the values could be changed by a minute or two. It doesn't matter, right? Then what do we do? Therefore, we can conclude angle measured is equal to, you have to take the average angle, 65 divided by 2, right? So you have to consider the average angle, that is the angle correctly measured using the spectrometer. Take this down and thumbs up once you're taking it down. So at the last class we discussed how to adjust a spectrometer, right? So adjusting telescope, adjusting collimator, then finally adjusting the prism table. So once you adjust all those, the spectrometer is ready to get angles, to measure angles. The spectrometer is ready now, right? Then we discussed how to get a reading, how to measure an angle using the spectrometer. So that is discussed under example 1. So from that point, today we'll be discussing the remaining part. So before that, I'll discuss one more example. Let's say example 2, right? Write down example 2. So this also is about taking a reading, right? In front of this, write if zero of vernier passes, if zero of vernier passes, zero of main scale, right? Okay, so just draw this with me. So this is the case, right? Draw this with me. So this is the prism table and the main scale, right? So here you have 0, 90 degrees, 180 and 270. Again here 360. 360 and 0 is at the same place. 360 and 0 degrees is at the same place, right? Then the let's say telescope is somewhere here. So this is the T1 position of the telescope, right? T1 position of the telescope, and the right vernier scale is somewhere here. So let's say it reads 15 degrees. So this mark is at 15 degrees. So, okay. So this is right vernier scale. Then apart from 180, another vernier scale is there. And it is like this. Okay. So this is regarding T1 position of the telescope. You know that with the telescope, main scale rotates, right? Main scale rotates. So this is for the T1 position of the telescope. Then let's say when you are getting a reading, you turn the telescope from this place to this place. Let's draw for that one. Again, 0, 90 degrees, 180, 270, and here 360, right? For the other reading, let's say for the T2 position, right scale reads 330. So 330 is somewhere here, right? 330 is somewhere here. So that is for the right scale. Then apart from 180, there's the another vernier scale. So 330 is like this. 0 of the vernier. Then here you have the left scale. For the left scale, let's say it is about 150, right? Then the telescope will be somewhere here. This is the T2 position of the telescope. So this is for the T1 position of the telescope, these readings. This is for the T2 position of the telescope. You can see the telescope is rotated, right? So with that, main scale also rotates. Right. Quickly draw these two, and once you finish, thumbs up. Right. So I'll put these values in a table, right? So for the T1 position of the telescope, T1 position here, T1 position this one, for the telescope, from the right scale, you can read about 15 degrees. Let's say here it is about 15 degrees, right? From the right scale. From the left scale, the difference is 180. So when you add that, left scale reads about 195 degrees. Okay, so these are just examples. Actually, there should be minutes values as well, but for the simplicity, I am not including minutes. Okay. Okay, so these are the two readings from the right vernier and left vernier for the T1 position of the telescope. Then you move the telescope to this position. From the right scale, let's say you read 330 degrees. For this one, you read 150. So you can see it is 180 degrees apart, right? take this table down. Right. Then you can write angle measured by R for T1 position. What should it be? For T1 position, no, angle measured by right vernier, using the right vernier. If you measure the angle means the angle that you rotate the telescope, right? From here to this position, you have to rotate the telescope. So here the angle measured from right vernier is what? From the right vernier, it is 15 degrees, right? From the right vernier, angle measured here is 330. So you have to subtract those two values to get the angle. So what do you get? You get 315 degrees. You get 315 degrees. So what's the problem here? You only rotated the telescope by a small amount, right? From here to here you rotate it. So when you are doing the experiments, you don't measure angles like this. So the measured actually what you have measured is this angle, right? It is not the angle what we need. So if you get a large angle like this, which is not possible, what should be the angle? Correct angle. To get the correct angle, you just subtract the values, but then you have to subtract that from 360 degrees. Understand that? This is the angle, right? But from the vernier, you got 315 degrees. In order to get this theta, you have to subtract 315 from 360. 360 minus 315. So it is, I think, 45 degrees, right? So 45 degrees is the correct angle. So whenever you get a large angle like this, you might get questions like this, right? If you get a large angle like this, if it seems not possible, just subtract that from 360 degrees. Then you get that small angle, right? So that is 45 degrees. So this is measured using right vernier scale. Then angle measured by left. Okay, left means this one, these two. So we have two angles. For T1 position, you read 195. For T2 position, you get 150. Here 195. Here you get, from the left side, you get 150. So when you subtract that, you get the same angle, 45 degrees, right? So both right and left vernier scales should read the same angle, right? Same angle. Because both are rotated by the same amount of angle. You read the same angle, right? But you don't get the exact values like this, right? The values you get may differ by a few minutes. But this is for simplicity. So the what do you get? You get the average angle. So what's the average angle? 45 plus 45 divided by 2. So that you get 45 degrees here. Right? We do this for the accuracy, right? To increase the accuracy, we read the angle from right vernier, then we read the angle from left vernier. You get two values. Then you get the average. So that is more accurate there, right? So you know whenever you get right and left sides, I mean more than 1 and take the average, it is more accurate, right? Okay, take these two down. So this happens when vernier scale has passed the 0 mark. Okay, simply whenever you get a very large angle that is not possible for the experiment, just subtract that from 360. That's all you have to remember, right? Okay, if you have taken it down, thumbs up. Right. So this is how now you know how to measure any angle using the spectrometer, right? Then we'll discuss about least count. Least count means the minimum value that can be measured using a spectrometer, right? Uh, Write the subtopic least count of spectrometer. Least count of spectrometer. Okay. So when you take the spectrometer, 29 main scale parts is divided into 30 vernier scale parts. Okay. 29 main scale parts divided into 30 vernier scale parts in the spectrometer that is available in the lab, right? And also main scale is in half degrees, right? Least count of the main scale is half degrees. Least count of the main scale, it is not 1 degree. That 1 degree also is divided, is split into 2. So the main scale least count is half degrees, right? So how do we find the least count? Least count, what do we call? Main scale part minus vernier scale part. Difference between main scale division minus vernier scale part. That is how we find the least count. So the main scale, one part of the main scale is 1 over 2. 1 over 2 degrees, half degrees, half of a degree. For the vernier scale, it is, how do you find that? 29 parts is divided into 30. So 29 main scale parts, 29 main scale parts is divided into 30. Correct? So the one part is half a degree, right? So the angle here is half a degree, 29. 29 half degree parts in the main scale is divided into 30 vernier scale parts. So from this one you can get the length or the angle of one part of the vernier scale. Okay, then you can take this half out, half degree out, then you get 129 over 30. Half degree 1 minus, so you get when you take the denominator you get 39 minus 29, 1 over 30. Half degrees times 1 over 30 is what? 1 over 60 degrees. 60th of a 1 degree. What is that? It is a 1 minute, right? 1 minute. So you can see, using the spectrometer, you can measure up to 1 minute. So that is the least count. Okay. Take it down. Take it down and thumbs up. right? So this is how you find the least count of the actually any measuring instrument, right? So you have to know that for the spectrometer, you can accuracy is up to 1 minute. 1 minute means 1/60th of a 1 degree, right? 1/60th of a 1 degree, right? Okay, now we know everything in order to do the experiments, right? Right. So for the 29th experiment, so once you know all these, doing the experiment is easy. Once you adjust it and know how to take a reading from the spectrometer, doing the experiment is easy. You just have to take the measurements, right? Right. So this is how you do the experiment.